First things first, we're not objective creatures. We don't make decisions based on anything objective. It all comes from subjective. So how does that correlate? Well, first of all, when you look at the human perception system and how we recognize creatures based on our subjective comparison sense, the way a cat looks visually, the face and the size, none of that matters. That's not how you do it. Here's an example, right? If you saw a German Shepherd walking down the street and it was walking past you, and in your periphery you just saw it leap up and land on it, like what looks like there's a fence and start walking, you wouldn't like look over and be like, is that German Shepherd walking along a steel fence? And it's like, oh, whatever. You'd be like, no, you wouldn't do that. You'd go over like, what the hell? What the hell's going on with this goddamn dog? Am I losing my mind? You'd look around, you'd check your blood. Like, am I awake right now? You're looking at because it's obviously a German Shepherd. But what the fuck is it doing on this fence? How'd that happen? You wouldn't, your whole day would be messed up. Why? Not because this cat looks like a dog, but because this dog is acting like a cat. And not acting like a cat, it's physically able to do things it shouldn't be able to do. So how does this map? How do you do that with AI learning? Stop doing this whole image stuff. Train them on videos, right? And then how do you get them to make the difference? Simple acceleration jerk values, right? Like just mapping, and not like getting specific objective ranges where you're like, well, the max acceleration ever acquisition for a dog was this, and then no. You just have relationships based on like, okay, I had to up my sampling frequency, kind of the way we do it, right? And then you have just like a comparison. Generally speaking, cats are going to have a certain amount of dexterity, certain acceleration jerk profile that allows for them to jump on fences and walk like this. Certain other things that you'll notice is the way in which the tail moves. So you see a cat or a dog or four-legged creature out in the distance, too far away for you to see what it is, but you see the tail doing like this kind of a thing, just like making an S, and you're like, oh, that's a cat, right? You don't need to see images. You don't need to see its face. You don't even need to see it moving. You just see that S shape in the tail, and you know that there's just no dog that's ever had the ability to create that acceleration jerk profile, even if it had the same bone structure. When you realize that we are an underactuated system, that underactuation creates a lot of opportunities to just basically use the correlations that the Earth has provided for us, right? Like, there's an example. There's a football player way out in the distance. Now, one of them is holding a paper football, like literally you can't tell the difference because it's just so well constructed and it's too far away. And another one's holding a real football, right? Now, would you want to try and tell what it is just based on like, the way their hand and trying to see if you can, just like, hey, just throw both of them, and then I'll tell you right away which one's real, which one's fake. Until you throw it, it doesn't even matter. You're just holding it. Like, why do I care? Until it's moving, it doesn't matter to me. So then how do you expand that? Have them interact now. How do humans interact with cats versus humans interacting with dogs? You're going to see cats kind of, whatever, you get some amount of information there. But then you're going to see a situation where humans going to make a command out of their mouth. The dog's going to start doing stuff, the human's paying attention to the situation, and then you're going to see their face respond to, the finalized command. And you recognize like, okay, there's a lot of scenarios in which a person will say or, make some sort of movement, the dog will respond, and then the human will then respond appropriately as well. Bang, 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 back and forth. You're never going to see that with a cat. So now instantly it understands that there's a certain amount of utility that can be gained between, from a dog for a human, then it's never going to get from a cat. You start to build up subjective meaning. Basically, you start to build up affective valence and subjective meaning, and then you try to take what you have subjectively and you try to use this clunky objective reality to convey that information to someone else. So you don't start objective, you always start subjective, because that's where the whole world is for us. So now I'm trying to take my understanding what's inside my head, my subjective, I'm trying to communicate it to you. But how you can't do anything with it unless you create an environment, and that environment is our ability to experience. You gotta be weird, man. When you feel something subjective, you just fucking do it. You can't allow yourself to be like, if if I act a certain way, if I do a certain thing, someone's gonna think I'm crazy. It's like, so fuck no. When you're giving it information to about the environment, you think to yourself, giving it better sensory information, more direct sensory information is better, but it's not. What you want is consistency, and you want correlations between these things. What I mean, it's like, all right, so for us as under-actuated machines, when we walk, right, when I move my leg, there's going to be correlations between me moving my leg and what I can do with this hand over here, because it's all connected via blood, the fluid system. You know, it's like when you stand up, right, all those arteries contracting to maintain the blood pressure right here. If I swing my arm around, the blood goes to it. It's all of that. It's correlated. So what would be another way to go about it? Have a car try and move around an environment, park itself, but instead of having like the diameter of the wheel in an exact way in which it knows I have traveled exactly this distance, you should have like a current, right? The current to the motor, right? And then now that current to the motor correlated to like the distance between it and some object that should be stationary, because you model that object as like a stoplight. Stoplights, as far as your model go, don't move. So you put a certain amount of current down, you get a certain amount out. You start to realize, kind of based on like where you're looking, that you might be on a grade going up or on going down. Tire pressure, you start to get all of these loose connections, and then you have the model build around that. So that way when something new comes, you're not trying to restructure this really, really solid, like, I know how it works type of a thing. It's always this kind of like heuristical, intertwined thing. So that way when something new comes in, right, you're able to adapt. You know, like the more structured something is, the more directly acquisition, the more certain it is, the less it's ever going to be able to change. So then how do we translate that now to what's going on with like image processing? You know, going down the street with all this data, and we're like tracking images, right? You see a car, it's like 95% confidence, it's going around a turn, 60% confident. None of that. We don't see anything as it is. We model to represent everything, right? This wall behind me, this is mostly empty space, but because we interact with it as a solid, we represent it as a solid. Colors, we know they don't exist. They're just energy, but it's the lowest representation that allows me to understand the difference for a utility that it provides. So how do we do this? Second, you look at the second that image recognition sees 95% confidence as a car, you just take some stupid thumbnail, some crappy little low resolution model of a car, you stamp that over it, you stop processing the image now, and now what you're doing is you just have lux and distance between that object be the only keys, right? So now you just take a little rangefinder and you aim at it, and it's like you just correlate that, and instead of reprocessing the image, you just move your model up. Instead of tracking millions of pixels and trying to keep this line around this thing, you just go, okay, over there is where it is. And it gets a little brighter, you just move your model closer, it gets a little darker. So because you're building this whole model based on acceleration jerk values, now it allows you to just kind of cut out a lot of unnecessary nonsense also with respect to motion. So once you stamp that model of the car on there, bang, that's a car, you're already going to have a lot of understanding as to where that car could end up. So instead of watching it go pixel by pixel by pixel, you just set a boundary box, right? Like this boundary box is going to give you, like, with respect to however much time you care, right? It can only accelerate so fast, right? It can only stop so quickly, and you see the direction it's moving. This is going to make it easier too when things start going behind objects, right? Because now you have a car, you have a person moving and stuff. All that processing now, instead of trying to, like, you know, calculate this car, whatever that object is out there, how you're going to turn your wheel and stuff. It's like, no. It's like all the other things don't matter now. Now you can put all of your processing into avoiding this edge case, right? So, like, you know, you're getting ready to try to make a turn really quickly, and you're thinking to yourself, well, you know, if I turn the wheel too sharp, then I risk like sliding, and then I lose all my. It's like, you know, now you can start doing all sorts of nonsense where it's like, so it's like, all right, if I tap the brake, it's going to load weight onto the tire, on the front tire, and that's the moment where you put the maximum turning. You know, all sorts of crazy crap. You look at the optic nerve, the optic blind spot, right? People will think to themselves like, oh, there's evidence that biology makes mistakes, or that God makes mistakes, and it's like, absolutely not. You're wrong. The optic nerve going right through our ability to see, that is benefit, not a consequence, right? Let's say you have some object out in the distance right here, right? You're going to focus on this. Now, you understand that for us, right? Like when I'm saying use a rangefinder, we're using our eyes with basic Pythagorean theorem. You know that that's going to give you the distance. You have the set distance where your eyes aren't never going to move, right? So for you to focus on something, that's triangulation. That's always going to give you a bit, like that's going to give you distance every time. Now, you don't recognize this because you don't understand that your conscious perception system, where we are, all we are meant to do is label data as good or bad and to decide whether or not to act or not to act. Every other aspect of our biology is controlled by the autonomic nervous system, which is why we can look over at something and your eyes will just lock on. So, how does it do that so effectively? Having these blind spots, right? If I tell you to focus in on this object, what's your ring? Is your focus? You're focusing this big? Like how it's very difficult to do so if you're just like it's arbitrary. So what does it do? You have these two blind spots that overlap, right? So imagine you go to like look at something, right? But then the blind spot's here and one's there. Obviously, that's not the case. You keep them symmetrical. So no matter what movement you do, as long as they are lined up, right? You got to look for something, like you got to focus in on something, but like you can get all this misalignment because it's very, very slight. So how do you fix for that? You just have these blind spots. These blind spots aren't going anywhere. But this one overlaps and can see for that one, and this one can see for that one. So what do? You just, no matter what, when you go to focus on something, you just keep those blind spots symmetrical. Never going to be a situation where you're going to have a blind spot a little higher, a little lower. Because what are your eyes, so then that keeps them level. And so now you get that perfect triangulation. You can move up, down, out and in, right? So now, you just replace that with a basic rangefinder. Stop with this LiDAR nonsense, trying to localize to a centimeter, trying to get curves and all this extra stuff. All this extra data is unnecessary, man. Probably just replace those cameras with like a 144p resolution, and every time you see something fuzzy, you're like, I think that's a car, you just stamp your car model over it. I think that's a person, stamp that on there too. Why? It just looks like something on the side of the street like this. It's like, well, I know pencils aren't big enough to be to be sitting on the street, and it's moving pencil. I'm just gonna go ahead and call that a person, put my person model on it. And until this like little person all of a sudden just flies off, and it's like, okay, I need to reevaluate. Maybe I should update my model to have a higher resolution to see a little bit better. But that's the only time you increase the data that you have available to you. You minimize. You want to reduce what you have to process. If you understand anything about flow state isn't you processing tons more data more effectively. Flow state is you getting so good at what you're doing that all of these variables coming in, you've locked it down to these two matter. So all these extra, you get rid of all that, you ignore it, and you're just killing it. You're manipulating these two, and everything else is just, you're not paying any attention to it because these two, all of your processing is there. So it's like you got your computer there, and your computer's doing all this multi-threading. It's trying to dedicate crap to the GPU. It's doing all this crap. But then flow state would be as if all that just gets dropped. Your screen, the graphics, everything just goes away, and it's just going straight in. The art of play. You gotta allow yourself to be silly too. If you try and keep everything structured, then you're going to stay structured. You're never going to get out of it, right? If you're worried that someone's going to think I'm crazy because I'm blah, then you're going to be stuck in a box. It's all about the subjective. You can't understand it because it is outside of your current knowledge. It's all about imagination and intuition.